Hello everyone and welcome to the session 6 of unit 6 unconventional machining for the course machine tool technology. So in the today's session we are all discussing about abrasive jet machining, which is also known as in short form AJM. So the principle of AJM, in case of AJM, the material is removed from the workpiece by means of the mixture of the air and the abrasive particle which are mixed at some portion and which strikes the workpiece at a high velocity by through a nozzle at a speed of around 150 to 300 meters a second is strikes the workpiece with a high velocity of 150 to 300 meter per second. The abrasive particles used in this are silicon carbide, aluminum oxide, and the powder are used for cutting the surface of the workpiece, and the mixture used it is mixed with the media air or carbon dioxide, and which strikes the workpiece with a high velocity that will remove the workpiece from the material from the workpiece by means of abrasive erosion. So this is the operation of the AJM. So let us go to the working principle of the AJM. So it consists of a gas supply. So it may be nitrogen or carbon dioxide or simple air is stored in this supply. So that is passed through the filters. So it will remove the any dust particle from the supply, and so that the pure air will be supplied to this mixture chamber. So this is the mixture chamber. Here the abrasive particles are mixed with the this gas. The gas used may be carbon dioxide or maybe nitrogen. So in the mixing chamber, the abrasive particles are dropped into this chamber so that it will mix us with the incoming pure air. So here the vibrator, so which is vibrates the mixture chamber, so that the abrasive particle and the gas uses mixes in a very accurately, so that the mixture will become a good quality. So after that the mixture of the gas and the abrasive particles used may be silicon carbide, or we have aluminum oxide of small grid size. uh, the grain should be of sharp edges, so the grains used here may be having sharp edges for cutting action. Should not be reused at the sharp edges. So if the sharp edges are worn out, they are not be reused. So after the mixing this gas and the abrasive particles, which may be silicon carbide or aluminum oxide, then it is passed through the holder. Then the after passing through the holder, it will passes through the nozzle, which further increases the velocity of the this mixture. The velocity at the end of the nozzle is at a speed of 150 to 300 meters per second. So this high velocity the mixture with abrasive particles strikes the workpiece with a very high velocity that will causes the erosion of the workpiece material from the workpiece, and that removes the workpiece from the material from the workpiece to the required dimensions. So this is the working principle of the AJM. So it consists of gas supply, so which is used maybe pure air, or that may be nitrogen or carbon dioxide is stored here. So after that we have mixing chamber. In mixing chamber, the abrasive particles are mixed with this gas supply. It means a vibrator which vibrates the mixing chamber. So after that it will pass through the nozzle, so that will further increases the velocity of the this mixture. So when with high velocity mixture is with abrasive particles having sharp cutting edges, it strikes the workpiece with a high velocity that will remove the workpiece material from the workpiece. So the required dimension or required the shape will be obtained on the workpiece. So the merits of AJM is the operation is very simple. Hard and brittle materials can be easily machined. There is no vibration. It provides cool cutting action. It can be delicate and heat sensitive parts without any damage. It can cut delicate and heat sensitive parts without any damage. The disadvantages is expensive process, not suitable for mass production. It needs dust control system. Abrasive may get inserted. Nozzle life is limited. Cutting motion is to be properly controlled. So before going to end this session, I will show the simple video. The application of AJM is used for composite materials, ceramics and glass, good materials that cannot be stand high temperature. So materials which cannot withstand high temperature, that may be plastic or that may be soft material, so it cannot withstand high temperature, can be easily machined by the AJM. It can also be used for deburring, etching, cleaning brittle metals, alloys and non-metallic materials. So I will show the video of the AJM
process. So guys, this is a non-conventional machining process, and we are going to learn in this video, that is the working principle of abrasive jet machining. We're going to learn its equipments and the actual process of abrasive jet machining. We're going to learn applications as well as the advantages and disadvantages of this process. So guys, let's begin with the principle of abrasive jet machining. So guys, this abrasive jet machining process works on a basic principle of abrasive erosion. So if a high velocity abrasive particles are strike on the hard or brittle workpiece, it tends to remove some amount of the material from that workpiece. So it removes the sum of the metal on the striking surface, or we can call it as a workpiece. So guys, as we can see in this image, the stream of the high velocity abrasive particles are bombarded on the our workpiece, which having velocity of about 200 meter per second, which goes to strike on the workpiece, and the distance about this nozzle and the workpiece is very low, about 2 mm. So this, at that point, the metal removal takes place. So guys, let's check out the equipments and the process which is used in abrasive jet machining. So guys, as we can see over here in this image, there are several equipments which is used in this non-conventional machining process, starting with the supply of the gas over here. So guys, the clean and the dry high velocity air or gas which is gonna use for the machining, which is mostly air, carbon dioxide, nitrogen we can use in this process, and which is used in this gas propulsion systems. So when we talk about gas propulsion systems, there are several components. The first one is the compressed air, which is stored inside the cylinder, which is compressed gas, which is followed by the isolation valve and the filters. So this compressed gas is then sent to the filler and a dryer, where all the dust and unwanted particles along with the moisture from the air gets removed, and now this clean air is sent to the mixing chamber. Now this clean air goes to the mixing chamber, and inside that mixing chamber the abrasive feeder is there, which feeds the abrasive particles inside the mixing chamber, which gets mixes with the air, and this high pressurized abrasive air then goes to the nozzle, and inside that nozzle the velocity of the abrasive particles increases tremendously, around 200 meter per second. That increases, and it goes directly on the workpiece, and it's directly hitted on the surface of the workpiece. So at that point the metal removal takes place, and this is guys the micro cutting action which is going to take place on the surface of the workpiece. So guys, in this case the brittle fracture of the workpiece is carried out over here. In this case it is used in drilling and cutting of the hardened metals. Over here we can cut also, and we can drill small holes also on the hardened metals. It is used for the machining brittle and heat sensitive materials like glass, quartz, sapphire, mica, ceramic, etc. It is used to manufacture the electronic devices, electronic components also. Also guys, it is used to deburring the small holes, which is not possible in our conventional machining due to the criticality in the machine parts. So we can use this abrasive jet machining. So guys, that was the application. Let's study the advantages and disadvantages of this abrasive jet machining. So guys, the low metal removal rate over here in case. So guys, this process takes some time, which goes under disadvantages, and we get high surface finish as the metal removal rate is very low. It can machine the heat sensitive material, as we can see in our sensitive materials. So to prevent the expansion of the workpieces over here in this case, that comes under advantage. And the abrasive particles can like embed it into the workpiece. If the workpiece material is soft, it can embed in the workpiece. It is free from vibration, this machine, that is the main advantage. So guys, the initialization cost is very low, which comes under the advantages as compared to the other non-traditional processes. Of course, this is very cost economical, and the thin section can be machined very easily in this case of abrasive jet machining. So the nozzle life is very limited in this case, so it's this nozzle needs a frequently replacement over here, and the abrasive particles cannot be reused in this process.
Thank you.